if the following series is convergent or divergent. So we got a series here and it starts from 5 through infinity, but the conclusion will be the same even if it started from n equals 1 or n equals 2. And notice these terms are all positive. I mean, there is no negative terms. And the bottom looks more complicated. So n plus 3 raised to 5 means multiply n plus 3 5 times, kind of. So why not we take a simpler series based on these terms. So these are an. So here an means the given general term, n plus 6 over n plus 3 raised to 5. Every term is positive. Okay, now based on this we can take a new series, okay, which is much simpler than this, and we know the conclusion about that series in a second. Okay, so take bn equals, since we have a fraction, so we always take the leading terms, n plus 6. For big n, plus 6 doesn't matter when we have n equals like say 1 trillion or something. Plus 6 doesn't count, so n. On the bottom, n plus 3 raised to 5. In fact, if we multiply n plus 3 raised to 5, we are supposed to multiply 5 times. Okay, this is not simply n to the 5 plus 3 to the 5. Okay, that's not true. Okay, we're gonna get 6 term. There will be big. Okay, but the first term will be n to the 5th plus etc. And I'm just taking the leading terms, so I'm going to take n to the 5th leading term from the bottom. N over n5, we can cancel one copy, 1 over n to the 4th. Now 1 over n to the 4th is much simpler than this, and we should know about the series containing terms bn. Let's see. Note that series bn, which is 1 over n to the 4th, n from, we need to match in the question 5 through infinity. This one, what do we know? 1 over n raised to power n raised to p. So this is a p series with p equals 4 bigger than 1. Okay, then this series converges, being a p series. In fact, p series means n equals 1 through infinity, but this is even smaller. So it's a partial p series. So this one converges. Note that this converges, being a p series. Okay, maybe partial p series. It's not optional, with p equals 4 bigger than 1. Okay, np, when p is bigger than 1, then this series converges. Now we want to use the limit comparison test. We want to find the limit at infinity of the ratio an over bn. If that comes out to be a positive infinite number, both series behave the same. That means since this converges, the given series, okay, this given series also converges if the limit happens to be positive infinite. Okay, so now let's find the limit at infinity of an over bn. In fact, you can do bn over n as well. Limit n going to infinity of an, which is the big chunk here, n plus 6 over n plus 3 raised to 5 divided by bn, which is 1 over n to the 4th. Let's change this division into multiplication. So n plus 6 over n plus 3 raised to 5 times, this division into multiplication means we need to flip this fraction, n to the 4th over 1, which is limit n going to infinity of, if we multiply, since this is limit at infinity, only the leading terms matter. We don't have to multiply throughout. So leading term means n to the 4th times n to the 5th on the top. And that's the leading term. There is another term plus 6n4, but that's not really needed. All over 1 times this is just that, and the leading term, like earlier when we multiply n plus 3 5 times, n plus 3 quantity n plus 3, the very first term will be n to the 5. Okay, and now this limit is cancelled, just 1, which is positive and finite. That means by the limit comparison test both series behave the same. Then by the limit comparison test, okay, this our constructed series, this new series converges, so does the given series. The given series, or given the question, given series in the question, also converges, converges. Final.